Welcome to another edition of Daily Airline News, focusing on the tragic loss of Air India 171. I'm Geoffrey Thomas, and I'm delighted to say, once again, joined by my co-host Richard Godfrey in Frankfurt, Germany. Good morning to you, Richard.
Yeah, good afternoon to you. It's almost evening, isn't it?
It is evening indeed. So, viewers, the episode we've got today for you is Water Ingress Explained. Now, let's start off with a few comments from viewers and then we'll get into some questions. The comments from Cessna 140 driver. Gentlemen, well done in the face of a deficient preliminary report. You have done a wonderful job. Thank you. And from EDESTQV, not just deficient, but deliberately deceptive and self-conflicting. And Karl Heinz Kampfer, 1963, I agree with most of the commentators' positive comments. A truly excellent analysis and consistent, thorough examination of the facts and the events. Wonderful and determined work by both gentlemen. Many greetings to both of them. And from Nem Eshar Sharma, 5737, as an Indian who has been following the updates of this tragedy, I am deeply thankful to you, gentlemen, for your detailed analysis and for pursuing answers from the AAIB. You're absolutely right that they should have sent over the data instruments to a more competent authorities immediately. I wouldn't be surprised at all if it turns out to be a giant cover-up of Air India. It would be a national embarrassment. And from Signal Electrician, here to Richard, saying we are primarily concerned with air safety. The elephant in the room is the lack of information in the initial report. Love this channel. And finally, Richard, a lovely note from Rob T. Pin 62 regarding his comment yesterday. Dear Geoffrey and Richard, I sincerely apologise if my earlier comment caused any offence. My statement, the absence of this evidence only leads to speculation, which causes further pain for the victims' families and friends, and does a disservice to aviation and aviation safety, was intended to be directly toward the Indian Investigation Authority for not including vital FDR, CVR and other technical data, thereby leaving room for speculation. I have great respect for the time and effort you have devoted to developing possible hypotheses based on the available data. It is an impressive piece of work. Congratulations. That said, I still believe it is premature to draw conclusions or identify a root cause at this stage. Sidney Dekker, a leading figure in safety science, has often cautioned that investigators are prone to hindsight bias, especially after a tragic event, when there can be considerable pressure from many directions to pinpoint a single cause of failure. I hope you can forgive me for not making my intent clearer in my original comment. So, that's Richard. That's a very nice comment from Rob to post.
Yes, it is indeed. And Rob, thank you for that. And apology accepted. And please accept my apologies that I misunderstood your intent.
Now, Richard, we've had a very interesting comment from Colorcraft Lab, which provoked a lot of reaction from viewers, pro and against. So let's go through this and let's get your analysis of it. He says, I'm confused about one point. If there was a water leak, I should say, which shorted out the equipment, which ultimately caused the engines to shut down, how did it automatically resolve itself in a matter of a few seconds? It is my understanding that once the fuel cutoff switches were flipped off and then back to on, there is some evidence to show that the engines began spooling up, indicating a potential successful relight. If the equipment was wet, how would this be possible? So, Richard, obviously Colorcraft Lab hasn't followed our episodes, but let's get your analysis of this.
Yeah, it's nevertheless an excellent question. And let me explain how a water ingress can cause a catastrophic problem, but then manage to apparently resolve itself as if nothing had happened. I think we all know that water and electricity do not mix, and water is a problem for electricity because it can make electrical currents flow in a way they are not supposed to, which can damage equipment and even damage an aircraft, and that can damage people. Pure distilled water isn't actually a great conductor of electricity, but tap water or potable water is not pure. Tap water, rainwater, lake water is ionized and contains charged particles. Your body is mostly salty water, and even small currents can affect your heart or your nerve functions. In a high voltage system, such as on a Boeing 787, moisture can lead to tracking or arcing across insulating surfaces, and this can be dangerous and destructive. Even a small amount of moisture or electronics in the power systems is a problem. In aviation, moisture control is a major design priority. Aircraft manufacturers used sealed connectors and coatings and desiccants in order to prevent moisture. And we've all seen silica gel in packaging we've received in order to keep moisture out and to keep the goods dry. And silica gel is also used on aircraft, by the way. Even a small amount of water can make the difference between a perfectly fine and dead electronics. In January 2013, a United Airlines Boeing 787 was parked at the gate in Houston. It experienced smoke in the cockpit and avionics bay. The investigation found that electrical arcing occurred inside the left main power panel, P100, which is located in the forward EE bay. And it distributes 235 volt AC from the engine generators to the rest of the aircraft. The arc severely damaged wiring, contactors, and structural elements of the power panel. Investigators found moisture ingress, possibly from condensation, contributed to a conductive film inside the panel, and this lowered the surface insulation resistance, allowing a leakage path and partial discharge to start, which then developed into a full arc fault. The panel's materials were not designed to self-extinguish under that kind of arc energy, so the damage spread. Now, I'm not saying that this is what happened to Air India. I'm only giving an example of what can happen to a parked aircraft, let alone an aircraft in flight, let alone an aircraft in flight at the point of rotation. The key question is, how can a problem with water condensation or moisture leaking onto electronics or electrical contacts then resolve itself? Well, moisture can evaporate, especially in a hot climate. And we know the temperature that day was very high. Condensation only forms at certain temperatures and during specific phases of a flight. The fault can come and go. If moisture dries up and the path clears, a system may automatically reset, or it could even be manually reset, restoring operation without anyone actually finding the real root cause. Some corrosion products, like certain oxides, are less conductive than the thin water film that caused them. And after moisture dries, these films can act like an insulator. That is, until vibration, further corrosion, or new moisture breaks in and breaks them back down again, and the insulation is gone. So it is perfectly feasible that an electrical issue comes and goes.
Well, I think we all know that with our motor cars, they come and go with electrical problems, which is very perplexing. But Richard, has what you've just described, has this happened before that an aircraft electrical failure occurred but then went away?
Yes, it has. There's a very interesting case which is well documented. An Air Canada Embraer E190 had an in-flight electrical failure and a so-called hidden bay fire. And that was on the 25th of May 2016, and you can look up the report. And shortly after reaching cruise, the E190 lost major portions of its electrical systems, the RAT deployed, and the crew descended to start the APU and recover power. And after landing successfully, thank goodness, maintenance found a fire and severe arcing in the Right Integrated Control Center, the RICC, in the avionics bay. The investigation determined a fluid contaminant, likely coffee or a soft drink, had entered the vent at the top of the RICC and contacted bus bars and the transformer rectifier unit number 2, causing arcing and a fire. And tests referenced by the investigators found that such fluids are far more conductive when wet, but once they're dry, the conductivity drops dramatically. So they were able, on the ground prior to the flight, to have a good systems test on the ground, but then when humidity and temperature or renewed wetting from cabin service or condensation took place in flight, then the residue became conductive again. And the big issue is the crew didn't see any smoke because the power loss took out the smoke detector and the recirculation fans, and they went offline before any smoke could reach them. And by the time the power was restored, the smoke had likely dissipated. And this is known in the aviation industry as a classic hidden bay hazard. So you get a fire and you don't even know about it because the fire detector is switched off or the circulation fans are switched off. And again, I'm not saying this is what happened to Air India, that coffee or soft drinks were spilled in the galley and tripped the electrics or caused arcing and fire. I'm just saying this has happened before, and I'm saying that electrical problems can come and go.
Yes, they can. And Richard, for the viewers that don't know how big the electronics bay is on a 787 or any aircraft for that matter, we're now showing an image of an electronics bay, and you can see it is very expansive. There's not just one computer down there, there are banks of computers. It's a very comprehensive it's the heart. It's the heart of the aeroplane, really. So
Yeah.
I hope
And
that.
on the 787, there are two, one at the
Yep,
front
front.
and
Yeah,
one at the aft, and there's miles of wiring under the
absolutely.
floor and over the ceiling and in the walls and
Yeah,
everywhere.
it is indeed. So yeah, so viewers, that's what you're seeing now. So it gives you a bit of sense of the area we're talking about. So Richard, on to a few more comments and questions. Sandy J342. The AC electrical system had issues when the airplane came in from Delhi and was probably not fixed. And Kawasi Kuta should have done repairs when air conditioner lights entertainment systems are not working because it might be serious. That's true. And Neil Hales, 4693, if water had been leaking during the previous flight while the plane was either in level flight or descending, there is always the flare of the previous landing to weigh against this argument, when quite a lot of water would have accumulated on the base of the electrical equipment bays, and on acceleration and rotation it would have flooded backwards and swamped electrics at the rear of the bay. Nice analysis of an unusual possibility.
Yeah, and to me it's interesting, and thank you for those three comments. The preliminary report makes no mention of the air conditioning and the cabin electrical service problems reported by multiple passengers on the previous flight from Delhi to Ahmedabad. They were either fixed or deemed not mandatory to be fixed before the next flight. But quite clearly, the aircraft did have some electrical problems already and air conditioning problems. Again, I'm not saying that those were relevant, and I'm not saying they were irrelevant to the Air India crash. The case is not proven whether these prior flight issues were relevant or irrelevant. The preliminary report simply states on the 12th of June 2025, Air India B787-8 aircraft bearing registration VTAMB arrived at Ahmedabad Airport from Delhi. The aircraft touched down at 0547 UTC and parked at Bay 34. The crew of the previous flight had made a pilot defect report entry on the stabilizer position transducer in the tech log. Troubleshooting was carried out and the aircraft was released for flight at 6:40 UTC. But it doesn't talk about the air conditioning, and it doesn't talk about the cabin electrical services, the in-flight entertainment, or anything else. So there were clearly other issues going on, and it would be nice to know whether they were fixed or not.
Indeed. So Rob H. 8890, in reply to Colorcraft Lab, I agree and thought the same myself. Richard's thesis is utterly preposterous and clear example of inductive reasoning and confirmation bias. He conveniently left out your point, which is so obvious from his analysis. Well, that's not very nice. And Anonymous, BI4IY, in reply to Colorcraft Lab, water ingress theory is most preposterous. One can still discuss it for academic reasons. I expect Geoffrey and team to clarify and eventually retract its hypothesis of insisting that the rat deployment before switches to cutoff. And AL Webby 83, rat deployment initiates secondary power in the event of power loss. To suggest Richard's analysis of this as preposterous is utter nonsense, with the rat delivering stable power 10 seconds after deployment, and I would expect the pilots initiated constant ignition and so the engines will relight. Remember, it was not the engines that failed. It strongly appears the primary supplies maintaining electrical failed catastrophically in terms that every critical system was lost simultaneously at the very worst time during rotation. Our hearts go out to those involved in this tragic loss. Sadly, it appears the crew nearly recovered the aircraft, but there are still people out there that believe the mainstream media and want to believe the captain switched the engines off at this low altitude. They want you to fear flying. There's a battle for the airwaves. Interesting comments, both for and against.
Yeah. Water ingress into EE bays is taken seriously by the FAA, and that's why they mandated checks and warned of the consequences of not doing those checks or not resolving any issues with the seal to the between the cabin layer and the EE bays below. So water ingress has happened before on aircraft, including the Boeing 787, and resulting electrical problems have caused in-flight emergencies and intermittent issues where problems have come and gone. The Air India Boeing 787 did have electrical problems on the previous flight, certainly with the stabilizer position transducer and with the air conditioning and cabin electrics. So in my view, this is not academic, this is not preposterous, it is very serious.
Yeah, it's very serious. Mark 21.4, there are multiple alternative sources that might have recovered the engine, but the time duration was not enough to recover the aircraft. Richard.
Yeah, and that's a fundamental observation and absolutely correct. And to understand engine shutdown and restart, you need to also understand the Boeing 787 electrical system, the fuel switches, the system redundancy, the backup architecture, and what the Boeing documentation has to say about all of those. I'm actually thinking of doing another technical note, putting all of those together. So you have an overview of the electrics, the fuel, the switches, the redundancy, and how engines can be shut down and how they can be restarted. It might be helpful for some to take a look at that.
And also take a look at some of the previous episodes we've done, and we've got a link in the description below to many of those episodes.
Yeah.
Now, Jeff Daniel, he's a regular, 814, I should say. The FADECs are part of the EECs and are located in the engines, not in the electronics bay. Hence, it is possible that the engines would be able to restart without whatever caused a problem after getting wet in the electronics bay. What I don't know is how is electrical power and hydraulic power routed from the RAT to each of the engines. It would be logical for RAT power to be routed directly to the key components it is designed to provide power to directly and independently from the normal routings.
Yeah, and that's a very important point, Jeff. Thank you for that. So there are forward EE-based systems and aft EE-based systems and engine systems in both engines, and they're all separate and run from separate power sources. They are, however, all interlinked, and the RAT, electrical and hydraulic power, is only supplied to the key components. And the Boeing has a very full system redundancy and a very clear backup architecture. So when the engines go out, the main battery will take over if the APU is not available. When the RAT comes online, the battery control unit will then switch from the main battery back to the RAT as the source of electrical and hydraulic supply. There is full redundancy because you have two engines, two EECs, two FADECs, two channels in each FADEC. And from the fuel switches, there are two signal paths and two switches and two poles on each switch and two relays and two separate power supplies. So there is a complete redundant architecture, but there are still single points of failure. And the essential backup power architecture, the batteries, the APU, the RAT, the BPCU logic, the SSPCs, are designed to maintain the critical DC feeds and support both the discrete sensing and the hardwired shutoff paths. You have to go through the Boeing documentation very carefully. So I'm talking about the aircraft maintenance manual, I'm talking about the system schematic manuals. There's a wiring diagram manual. There are system description documents. There are component maintenance manuals. And you need to go in depth into all of these systems before you can come to a conclusion.
Doreen Lindner, 2579. That was my genuine question too after watching yesterday's episode. How does the fact that the fuel switches were moved manually to the cutoff position fit into this theory? The switches seem a crucial point in former episodes and may be important enough to even be mentioned in the preliminary report, but now they don't matter at all in the crash scenario Mr. Godfrey is describing. I really like to understand this.
Well, Doreen, let me try and help. As you mentioned, we've done a complete episode on the fuel switches. It was episode 143. And the current episode you're referring to, episode 180, is titled Root Cause. And we were focusing on the root cause. We've done another episode, 154, which we titled Cause and Effect. The fuel switches were not the root cause, they were an effect of the root cause. That doesn't mean that they don't matter at all, and we've never actually stated that. So what we are saying is the root cause was water ingress. That caused engine shutdown, and they were successfully relit, as we pointed out. And in between, in the process, as a result of the root cause, the fuel switches were moved. Some viewers still insist they weren't physically moved, it was just the function that was changed to off, cut off, and then back to run. I actually disagree with that view and say the fuel switches were physically moved in the cockpit. But I'm also saying that could have been a recycle of the switches, an attempt to reboot the FADEC into doing a relight. And I'm not saying it is obvious and proven that it was a deliberate act by the captain or by anybody else to down the aircraft. And what we've said in the past about the fuel switches is there are two separate signal paths for redundancy and safety reasons. You have the one path via the 28-volt bus, DC bus with the relays, and you have another one via the RDC to the EEC and FADEC system. And you have to consider that switch is a two-position, two-pole switch, and each pole is electrically isolated. But both poles can indeed be fed from the same 28-volt DC bus. And typically, the left and right DC buses are per engine, but they can be tied buses. And that is common practice. And each engine's switch normally sits on its own side, left or right, DC bus. And a single bus failure shouldn't therefore take out both engines, and both engines shut down. But a total loss of that local DC supply could give you a false indication of a loss of the relay drive. And there is a bus level failure, not a switch design failure, which is a single point failure. And in previous episodes, we've talked about the fuel, episode 120 and 138, engines in episode 144 and 163, the avionics in episodes 125, 141, 157, the FADEC in episodes 178 and 179, and the RAT deployment in episodes 118, 160, 172, and 173. In total, we have described the dual path fuel switch function, the rationale behind the redundant electrical design, and the RDC signals and the relay drive. We've also described the significance of the power source segregation. We've also listed the different manuals and what they can contribute to the complete understanding of the system. So we are doing our best to help you understand.
Richard K. Liesler. Yes, and it is very obvious it was a deliberate act and is being treated as a criminal investigation, not an accident at present. And Kawasi Kuta in reply, really, some people are pigeon-brained. These things have nothing to do with anything. And Petra Khan, baseless nonsense is invariably not possible. There you
Yeah,
go.
well,
Some
some
interesting
interesting
comments.
backwards and forwards. And
Yeah.
it seems that there are very polarized views out there. One, it's a criminal investigation and the criminal's already been charged. And the next one's saying it's pigeon-brained to come up with such an idea. But I have to say, I do like Petra Khan's summary. Baseless nonsense is invariably not possible. And we have talked about water ingress into the EE Bay, and this has happened before, and it will happen again if it's not taken seriously. Galleys have been flooded, as was the case on the Qantas flight QF2, London to Bangkok, and it experienced a serious electrical malfunction during the descent into Bangkok International Airport. It was about 15 kilometers out, and the cabin crew reported a substantial water leak in the forward galley. And they used several blankets to try and soak up the leak. The cockpit observed that their displays began with various electrical warnings, multiple bus control unit messages, AC bus failures, battery discharge alerts, flickering ICAS pages, with screens going blank. Electrical power losses degraded communications, navigation systems, flight displays, instruments, and they even were reduced to one radio channel, but fortunately the ILS remained functional. The galley drain line, it was found, was blocked by ice due to a failed heater, and this caused water to overflow and leaked into the equipment bay. And water flooded several generator control units, causing 3 of them to fail and shut down. And you can read all about that in the ATSB report on that incident. So this is not baseless nonsense, because it has happened before and it will happen again. And it could well be that water ingress into the EE Bay was the root cause of the Air India crash. And that is our current hypothesis that we have put forward. And it is neither nonsense nor is it preposterous.
No, it's certainly not. It's a very, very well thought out, after exhaustive investigation and some really very, very clever science on your part, Richard. So, Richard, thank you very much indeed for that fabulous water ingress explanation. So thank you very much indeed. Viewers, thank you very much indeed for watching. Thank you for subscribing to us. If you don't, please do. Thank you for your wonderful comments and fabulous support. Please keep those wonderful questions coming. And Richard, we're going to be back tomorrow with an episode on those crash investigations that were flawed or were cover-ups or were disputed. And I think viewers will find that absolutely fascinating. So viewers, please do tune in tomorrow for that. I'm sure you'll find it really interesting. So Richard, thank you
Yeah,
again.
you're welcome.
And viewers, please do tune in tomorrow. We really like your company and we appreciate your support. Thank you very much.